Okay, we're looking at compound interest. So. So we can start with $100 at 10% annual interest compounded annually. We're going to track the value of this investment for 3 or 4 years, okay? And then we'll go on and figure out what it would be after 20. Okay, so at year 0, that's when we start. Okay, we got $1,000. The interest we get is 10% of $1,000, which is $100. Okay. So after 1 year, we get to add that $100 to the $1,000, we get $1,100. Now, how much interest do we get this year? We don't get $100 because we got $1,100 in here to have interest to calculate the interest. Okay, so we're going to interest is going to be 10% of $1,100. So $110. We're going to get to add that to the 1,100. So after 2 years, that's going to give us $1,210. Now, go ahead and figure out the next few years there. See what you get. Figure out 2, 3 more years. And so what we get is it's easy to do 10%. I figured 10% because moves the decimal over one place. And if you're doing a more extensive calculation, that's fine. But you're gonna have $121, okay, of interest on $1,210. So in the next year, that's going to give you what? $1,331. Then you do 10% of that. You get $133.10. Okay. And you don't skim that 10 cents off and go buy yourself a Coke, which when I was growing up was the price of an 8-ounce Coke. Okay. And I had a buddy who's always trying to bum a dime from it. He was the best friend I ever had. He was worth it. So once in a while I give him a little money. So we add 1331. Now if we add 100, we're going to have 1431. We have 32, we're going to have 1464. I think that's going to be 1464.1. You know, see the binomial expansion there, so I kind of believe it. Well, then we can do it's 7. Okay. Makes sense. So every time we compound the interest, we're compounding it based on the money we now have, which is how compound interest works as well. And this turns out to be an exponential function. Now, we're not going to quite do that yet. I'm going to do the same table in a little more detail. Okay, so we got T, we got the amount, we got the interest, and then we got the new amount. And I'm going to write these out just a little bit differently. Okay, so we got 0, we got $1,000, we've got $100, and there's another step that I just came up with it. Okay. No, I do want to write this out. I'm going to do that 2 steps. I was going to say my new amount is 1,000. Plus 0.1 times 1,000. Okay. In other words, instead of just calculating the interest, I'm gonna calculate the new amount. This is my interest. That's just what I got here. So I'm gonna add it to the 1,000. So that it's equals 1 over 11,000. Now, what's my new amount? I'm gonna write it this way. Yeah, I read it right, okay. Okay. That's 1,100 plus 0.10 times 1,100. So in the second year, that's gonna give me 1210. And then it's 1210 plus 0.10 times 1210. It's there. Okay, now I'm gonna write it out in a little more detail. I'm gonna leave myself plenty of room to write the new amount. And I'm gonna leave myself plenty of room to write the amount. Okay, well, the new, and I want to leave myself even a little more room, which is saying that's out of them. Okay, so my amount is $1,000. My new amount is $1,000. Plus 0.10 times $1,000. So after year one, what's my amount? Well, it is $1,100, but I'm gonna write this, it's 1,000. Plus 10% of 1,000, okay? So now my new amount is gonna be my old amount, which is 1,000. I still don't have enough room, so I'm gonna have to erase this table. So we already know that table, we can do that, okay? So what I've done is I've written my new amount this way. And here it is again. And then here's 10% of the same thing. Now, the next step, my new amount is going to be all of this. And I don't have room to write it. I'm going to write it a little more briefly. And I'm going to make an observation. So to just use X for the amount, we're not going to solve for X or anything, but whatever the amount is, we'll call it X. Actually, let's go ahead and call it A for amount because it won't invoke the whole idea of the we got amount plus 0.10 times the amount. You have to agree with me that this is same as the amount times 1 plus 0.10. No, you don't have to agree with me, but not compelled to agree. But do you agree? Because if I distribute through here, A times 1 is A times 0.10 is 0.10A. Okay, I want to use that. So I'm going to write the table again. Okay. So instead of writing 1,000 plus 0.10 times 1,000, I'm going to do just 1.10 times 1,000. But you know, that's even a little too long. What's 1 plus 0.10? $1.10, right? So to add 10%, all I gotta do is multiply by 1.10. Okay. Okay. So I've got this now. That means here I've got 1.10 times 1,000. What's my new amount going to be? It's going to be 1.10 times this. Well, let me write this as 1.10 times 1,000. So it's going to be, I've got to add 10% to this. So I've got to multiply it by 1.10. And of course, how could I write that? 1.10 times 1.10 is what? Well, it's 1.21, but it's 1.10 squared, and that's what I'm going to write it. So this is 1.10 squared times 1,000. That's the briefest way I can write this. Okay, so in this year, I've got 1.10 squared times 1,000. And how much interest am I going to get on this? I'm going to get you know, 1.10 times this. Here I have 1.10 times this. And okay, so how am I going to write that out? Write that out for me. What's 1.10 times 1.10 squared times 1,000? Okay, now what we're doing is working on understanding compound interest. And understanding where this formula comes from that nobody can remember. But everybody's going to be able to solve it as soon as we get a little more experience with logarithms. Okay, well, here we have this. Obviously, if we multiply 1.10 by 1.10 squared, we get 1.10 cubed. And now in the third year, we got 1.10 cubed times 1,000. And then our interest is going to be 1.10 times that. And of course, that's another 1.10. So every year we multiply by another 1.10. Okay, so what I want to know is now, how much are we going to have after 20 years? Okay, what we see is that every year we multiply by 1.10. So after 3 years, we will multiply by 1.10 3 times. Did it once here to calculate this one, then another time, then another time. So after 20 years, we will have multiplied by 1.10 20 times. And then we didn't have to do years 5, 6, 7, 8, 9, 10, 11, 12, right? Didn't have to do every year because we're multiplying by 1.10 this many times. That means we're going to have 1.10 20 times 1,000. That's approximately $7,000. That was my mental calculation, but I'm using the rule of 72 to do that. It's almost 3 doublets. Okay. And that's only the approximate. Do it your calculator. Somebody came up with 6,700 and something. That's going to be it. So it's approximately $7,000, okay? So. What is it after end year? Amounts 1.10 to the n times 1,000. Okay. And instead of n years. That's totally appropriate. I'm gonna do it anyway. If T is your time in years. Then this ought to be 1.10 over T times 1,000. Now, really, n is a better number, but for what we're gonna do, I'm gonna use it. Okay. N is a better symbol because this only applies to whole number of years. Okay. So T usually we think of being as continuous variable, it could be 4.78 years or 9.32 years. That's not really rigorously possible unless we have continuous interest. Okay, this only kicks in on the whole number of years. So the point is we want to move toward continuous interest. So what we're going to do next is we're going to compound twice each year. Now, that doesn't mean I'm going to give you 10% interest twice each year. That means I'm going to give you half of that 10% twice each year. So I'm going to give you 5% after 6 months, 5% after another 6 months. Okay. Well, that's pretty easy to do. Okay, see. I'm going to abbreviate this quite a bit. T is 0, the amount's $1,000. Now, how much are we going to have after 6 months? And the rule is we get half of 10% twice each year. How much are you going to have after the first year? Careless wording. Want to know how much we have after the first compounding? That's after 6 months. T is a half. Okay. And then see if you can figure out what we have after the first year. Okay, so T is 1/2. That's half the year. What's our amount going to be? Well, let's kind of work it out to the side here, just so we are sure what we're doing. So first 6 months, make sure I'm visible here barely. Okay, first 6 months. Get 5%. Now, let's just remind ourselves the amount plus 5% of the amount equals 1.05 times the amount, right? Just like amount plus 10% of the amount, amount times 1 plus 1.0. % means 0.05, means per 100. 5 divided by 100 is 0.05. So it's easy to lose that 0 there, because we're used to just writing the number over here right next to the decimal. Okay, so we can't put a 5 right next to the decimal, that'd be 50%. Okay, it's 0.05. So this is the amount plus 0.05 times the amount. So we'll have what? Be 1,000 plus our interest. We could write that compactly as 1.05 times 1,000. Now, if I'm going to imitate what we did over here, then I gotta say, people are not really writing down the details of these columns. Probably understand it better if you do, but it comes down to something pretty simple. We're gonna have 1.05 times 1,000, right? And then what are we gonna have after 1 year? Well, that's another 6 months. So we're gonna do 1.05 times this. Okay, it's gonna be 1.05. And that's 1.05 squared times 1,000. Now, if you take your calculator and do 1.05 squared, you're not going to get 1.10. Just say this equals think you're gonna get, if I've got that decimal right, you're gonna get an extra $2.50 over what you would have had after the first year here. Okay, you do 1.105 squared times 1,000. 1.105 squared, I think, is 1.1025. Yeah. That comes out that. And all I'm doing is I'm using a plus b squared equals a squared plus 2ab plus b squared. Or a is 1, well, I'm just doing 1 plus 0.05 squared. Okay, simple algebra. Okay, you don't need to know that, but okay, now I'm not going to actually calculate that number each time. We just want to get the pattern. We got 1.05 squared times 1,000, right? And we calculated it here to show that we get a little more money when we compound it twice. Why do we get more money when we compound it twice? Well, here we're multiplying that whole 10% just by the $1,000 we started with. Here we get to multiply it by 0.05, okay, to get $1,050. And then we multiply that by 0.05, and we're multiplying a bigger number times that 0.05. Okay, we get halfway through the year and we take half of our interest and apply it to the bigger amount, giving us more at the end of the year. Now, at the end of 20 years, we'll get that in just a minute. We're going to get more than that $6,700 or whatever. Might not be a whole lot more, but it's going to be enough to buy a good dinner, probably. I don't know. I haven't figured it out. I don't want to think too hard. Use up all my brain power before my next 2 classes. Okay. And the third is multivariable calculus. That was actually much easier for me to teach than these are. In these classes, I've got to figure out what you're thinking. In those classes, they've got to figure out what I'm thinking. Of course, I still need to figure out what they're thinking, but it's a little easier because we have less variability in what people think. By that point. Okay, that's totally aside. But anyhow, after a year and a half, you get to multiply every half year, you get to multiply by 1.05. So we get 1.05 cubed times 1,000. Now, after 2 years, we do 1.05 cubed times 1,000. Well, we do 1.05 times 1.052 times. This is what we got. So, okay. So. But let's just keep track of where these numbers are coming from. Here's what we have after half a year. Here's what we have after a year. Here's what we have after a year and a half. And now we're in the same pattern. Every half year, we multiply by 1.05. So the power of 1.05 goes up. So after 2.5 years, then after 3 years, that's 50,000. Okay. Now, what are we gonna have after 20 years? Okay, now I pose the question, how many times, what are we gonna have after 20 years? If they also gave you the hint, how many times do we compound in 20 years? Okay. Well, we're compounding twice each year. 20 years, we're gonna compound 40 times, aren't we? Okay. And we can look at the pattern here. After 2 years, we got a 4 here. Why do we have a 4 here? Because we compounded it 1, 2, 3, 4 times. Okay. So all we gotta do is double this number, double the T. We get this, so it's gonna be. This. Now we gotta move on. We do have to talk about solving exponential equations. So we're gonna move through this just a little faster, but let me show you how we could write out the calculation. This is function notation. This stands for A of 20, the amount after 20 years, right? One point oh five and the 40 times 1,000. Now, what does that mean? 1.05 is 1 plus 0.05. 40 is 2 times T. And the 1,000 is what we started with. Okay, now you understand where we want to put 2T here, because if T is 3, power is 6, T is 2, the power is 4, T is 20, the power is 40, because we're compounding twice each year. Now 5.05 is because our annual interest is 10%. There's our 10%, and we're dividing it by 2 because we compounded twice a year. And that's where the 0.05 comes from. And then it's times 2T. And there's our 1,000. So let's look at this. Does this make sense? It makes sense because we understand we're always taking 5%, which is the same as adding 5%. But say it again. We're taking half our interest, right? Half our 10%, that's 5%, and doing it twice each year. We're doing 5%, then we're going to end up with 1.05 times what we had 6 months earlier. Here's where our 1.05 comes from, but 1.05 is what we got when we divided the 10% by 2. Okay, so 2 is our number of compoundings. N is our rate. N is the number of compounding. In this case, N equals 2. If we compounded it 10 times a year, we'd have to divide our 10% by 10, wouldn't we? Okay, so whatever our rate is, in this case, it's 10%. In this example, and is how many times we compound it, that's 2. And what do we do with that? We divide our 10% by 2, we divide our rate by n, and we multiply, we raise that to the power mt because that's how many times we compound it. So I'm gonna write that out with a bigger, with some notes. So this. In general, that's something else. I think maybe the formula you book uses. I don't know.
Hey,
Is it A?
are you recording?
Well, this is a formula in your book, except of course I got a letter for 1,000, what we're discussing is, what's that letter? And that letter would be P. Okay. R is your point, yeah. That's your annual interest. N equals 2, that's your number of annual compounding. That's your initial amount. So this formula says, in this case, you take half of your annual interest rate, half your 10%. And then in 2 years, you got to do that. NT, which is 2t times twice each year. You multiply the number of years by 2. And you get what we just got over here. And this applies no matter what your rate is, no matter how many times you compound it, and no matter what your initial principal is. And so here's your A of T. Now your book just uses A, I think. But I like to write this as a function A of T. And that's what the heck it is. Okay. So in this case, A of T has to equal 1 point. Yeah, I'm gonna write out the word. And what kind of a function is this? This is an exponential function with base b. B equals 1.05. Actually, the base is 1.05, it's 1.05 squared. Okay. B to the two T is the same as B squared to the T, and rules for exponents. Kind of go forward and backward. It's 1.1025 to the T. Now, that's an exponential function. There's your vertical stretch, there's your base, there's your function. I think they doubled in about 7 years. Okay. Well, the statement I just made, the thing doubles about 7 years. C, it doubles in about 7 years, we gotta use logarithms. So we're gonna talk about logarithms. I'm gonna cut to the chase in this thing. A equals B to the C. And this is just a simple exponential function. It's equivalent to log base C, log base B of C equals A. We're going to use this. Find the doubling time of this function. Probably better. Another board. We already figured out that if the rate is 10%, n equals 1, n is your number of annual compoundings. That means you compound it just every year. You go back to the first table that we made, that I raised and developed, okay? And we saw that you had 1,000 times 1.1 over the t. That's a simple function. I don't want to use this because I don't want to carry that 1.1025 around. I could do it for this one too. Okay. Well, it's then going to be 2,000 after it doubles once. It'll be 4,000 after it doubles twice. It'll be 8,000 after it doubles 3 times. Because every time it's right before it doubles. Okay. We're gonna solve the equation. 1,000. Times 1.1 over the 2 equals 2,000. This is a really easy equation to solve if you can use this. Now, looking at that equation, what's the first thing that you could do algebraically? I give an immediate response to that to divide both sides by 1,000. So we're going to do that. Well, clearly the 1,000 divides 1,000 leaves you 1.1 over the t. 1,000 divided by 1,000 is 2. Now, this equation here is in either this form or this form. Which form is it? I'm missing. Okay, so the question is, which of these forms do we have here? Okay. It's this form because you have your variable in an exponent. In this form, you got a log in there. There's no log in this equation. Okay. Also, what about this equation? Is this equation in this form or this form? This equation, before we divided by 1,000 and got this, was not in either of these forms. Okay. Because you have something to power, that's like your b to the c, you got a number in front of it. There's no number in front of b. There's no 1,000 in front of b here. Okay. So if there's a number in front of your b to the c, you got to divide both sides by that number. Then you're in this form. That's why we did the obvious thing. Now I just asked. It's the obvious thing we did. Well, divide by 1,000. Turns out that's exactly what you have to do with this, which isn't quite in this form. You get this, which is in this form. You gotta see that. Whether you totally understand what I just said. So, okay, this is like this. So this is the form. A equals b to the c. The comment was, look at a equals b to the x. And I commented, I don't like using x there because first example is going to see has a t here, and if there's supposed to be an x there, it's going to confuse you. And so I like to use totally neutral letters, except that the b, that's going to be an important letter that we want that to be b. Okay, this is form a equals b to the c. Now, in order to use the equation, you need to figure out what a is, what b is, and what c is. So write it down. A equals what, b equals what, c. Okay, to use this, we have to identify a, b, and c. Now, I would say, well, A is the amount. Well, A stands for amount usually, but sometimes not. And sometimes it stands for something that you wouldn't really think of as an amount, but usually it is an amount of some kind of quantity. But the thing that's easy to identify, and the thing maybe you want to focus on, is the exponent. So we got to that very quickly. Okay. So what's the exponent down here in this equation? Well, t, isn't it? Okay. So c is your exponent. Maybe I should have used e instead of c. And then okay later. I did. I went with a price. That was okay. So now we've identified the exponent. So what's the base? Well, it's the thing that's raised to the exponent. In this case, it's 1.10. And then what's a? Okay, A is not your amount anymore. Your amount's $2,000. Okay, so A isn't really the amount, it's the number on the other side of the equal sign. So A is, it's a number on the other side of the equal sign. Okay, so now, can you take these three numbers and write out this expression? Don't take time to copy down everything I wrote. You can do that in a couple of minutes if you need to. Just jump right to, if A is 2, B is 1.10, C is T, then write out this expression. Okay, we have to systematically identify our A, B, and C in this equation. And then we can write out A equals B to the C. So we got A equals B to the C. Becomes A is 2. Just find out, here's A is 2. But, sorry, we're doing A equals B to the C becomes log base B of C of A equals C, and I wrote this down there. Okay, so what I asked you to write down was going to be right, and that was going to the thing I did. Okay, so again, we see this is this form where A, B, and C are easy to identify, and then this equation becomes this. Okay. So that's going to be log what? Log is going to have a B. The B is 1.10. We put 1.10 here. Of A, which is 2, equals C, which is P. Now, I got to put this in your calculator. Using the rule that says log of the base B of whatever is the log of this number divided by the log of your base. Or it could be the natural log. Doesn't matter which log you use, as long as you use the same one for both. Get a T that's close to 7. Okay, now don't make the mistake of thinking that this 1.10 is multiplied by the 2. This is a subscript. It tells you what the base of your log is. And we'll talk more about that in pre-calculus class, and you'll talk about it if you're not in my class, in your class, but there it is. So that's just an outline of this method. But now we can see, I said that this exponential function should double in about 7 years. Now there's the rule of 72 that you're going to read about. It says 10% interest, you divide 10%, divide 10 into 72, you get 7.2. Okay. And I would say 7.2 years. Okay, now that rule only applies to small interest rates in a certain range, but it's never exact, except for one specific number, maybe. But in any case, this is what you get. So I didn't do any genius level calculation to figure 7 years. Okay. Just divided 10 into 72. Okay. So But you want to be able to do it exactly, and you want to be able to solve that equation. The original question we had was continuous compounding. I'd like to get into the definition of E in a class. It's always been a struggle. Continuous compounding. You'd have A equals 1,000 e to the R2. So you have A equals 1,000 e to the 0.10t. You would apply the same rule. Then you would get depending on what A should be. Okay. Find P. A equals 5,000. Okay, you have 5,000 is 1,000 e to the 0.10t. You divide both sides by 1,000, you get e to the 0.10t equals 5. This is the form A equals B to the C. So A equals 5, C equals 0.10t, and B equals E. So you get log base E of 5 equals 0.10t. When you plug all those numbers, when you identify your A, B, and C, this is what you're going to get. So it's just like what we just did. Okay. Now log base E is natural log. So T is a natural log of 5 divided by 0.10 equals whatever you get. Okay. So the steps are identical to the ones we just did. The only trick here, once you identify your A, B, and C, is to understand log base E is the natural log. Okay.